Why use the shaft basis system for mechanical tolerances? Imagine building a machine where every part fits perfectly without wasting time or money. That's where the shaft basis system comes into play. It's a method used to control how parts fit together in mechanical design. When engineers design a shaft and a hole, they need to decide how tight or loose the fit should be. This is where tolerances and fits come into the picture. Tolerances tell us how much a part size can vary, and fits describe how tightly or loosely two parts will connect. In the shaft basis system, the size of the shaft is kept fixed as the main reference point. The maximum size of the shaft is called the basic size, and it stays the same. The hole size, however, can vary within certain limits. This means the hole can be made slightly bigger or smaller depending on the desired fit. If you want a loose fit, the hole will be made a bit larger. For a tight fit, the hole will be slightly smaller. This approach makes it easier to control how parts assemble and function. One big reason to use the shaft basis system is that shafts are often made in large quantities with very precise dimensions. Fixing the shaft size simplifies manufacturing because you only need to produce one standard size. Then, you can adjust the holes to get the right fit. It saves time and reduces costs because you don't need to make many different shaft sizes. Instead, you just change the hole sizes to match the shaft. Another advantage is that manufacturing holes is generally easier and more flexible. Holes can be machined or reamed to different sizes without much trouble. This makes it simple to produce parts that fit perfectly with the fixed shaft size. It also helps in quality control because inspectors can use standard gauges to check the shaft dimensions. If the shaft is always the same size, it's easier to ensure every part meets the specifications. Using the shaft basis system is especially common in applications like motors, gearboxes, and rotating machinery. These parts need to fit together smoothly and reliably. By fixing the shaft size and varying the hole size, engineers can design 4 different types of fits, whether they want the parts to be loose, tight, or somewhere in between. This method streamlines production, cuts costs, and makes assembly more straightforward. In short, the shaft basis system is a smart choice when the shaft is the controlled element. It allows for easier manufacturing, better quality control, and flexible fitting options. This approach helps engineers create reliable, cost-effective designs that work well in many mechanical systems.